in this real life example, what we're doing is we're trying to find the distance of a ski run at a ski resort. So taking a look at this, they give you an angle of depression. That would be an example of that would be if you're standing at the top of the ski slope looking down the ski slope. If you go from an angle of level and follow and create an angle looking directly down the ski slope, you would see that it's a 20-degree, and that's what we call an angle of depression because it's looking downwards. So if you were like in an airplane looking down at an air tower, air traffic control tower, you would be looking down at an angle of depression. Now, if you're at the bottom, you're in a group and the rest of your group's at the bottom of the slopes, and they're looking up at you, the angle from level at the bottom of the hill looking up would be what we call the angle of elevation. Now, the angle of depression and the angle of elevation are always going to be equal to each other. Here's an angle of depression. Here's an angle of elevation. The reason they're going to be equal with each other is because level at the top of the hill is going to be parallel with level at the bottom of the hill, making these two angles alternate interior angles. So the angle at the bottom of the hill looking up is also 20 degrees. We're going to focus on our angle of elevation for this problem because that moves the 20 degrees from being outside of our triangle to inside of the triangle. It's going to be more valuable to us right there. Now we have we have two other sides here that look like they're pretty important. The D is the distance of the run of the slope, which is what we want to find. So we're probably safe leaving that as a variable for right now. The X is the vertical drop. Now that vertical drop is probably something that we need. We don't want to have two different variables in our problem, so we need to look for some other information that might help us to find that vertical drop. We see up here that at the top of the hill, we're at an elevation of 5,500 feet. At the bottom of the hill, we're at an elevation of 5,018 feet. So we can calculate that vertical drop simply by subtracting the elevation at the top of the hill minus the elevation at the bottom of the hill. 5,500 minus 5,018 puts us at 482 feet. So we have a vertical drop of 482 feet. That gives us enough information for us to calculate the distance of our ski run. So we're going to look at a little bit of trig. We're going to keep in mind we have SOHCAHTOA, we have our angle of perspective down here, we have our opposite leg here, and our hypotenuse here. So looking for our opposite and hypotenuse tells us that we're going to be using our sine function. We're going to get rid of cosine and tangent. We're going to set up our equation. We're going to plug in our values. Our angle value is 20. Our opposite side has a length of 482. Our hypotenuse has a length that's represented by d. Because our denominator has a variable in it, we're going to diagonal exchange these two values, moving the d up here and moving our sine 20 as a full unit down to the denominator. So we end up with this result down here. This is something that we can calculate here, the 482 divided by the sine of 20, which gives us an answer of 1,409.3 feet. That is the approximate length of that ski run at this ski resort.